Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 7, Lesson 1 on exponents. Now Unit 7 is all about exponents and they are extremely important in mathematics. And you've used them for years now. I think you saw them as early as 5th grade math. So, this is maybe your 4th year looking at exponents. But today what we're going to do is we're going to dive in, do some basic review on exponents, and we're going to also get into one of the first what's known as exponent rules. So let's dive right into them. Now multiplication, right, is our way of representing repeated addition of the same number. Exponents, however, are our way of representing repeated multiplication by the same number, right? So sort of, if you will, exponents are to multiplication as multiplication is to addition, right? They truly are analogous ideas. So let's take a look at that in exercise number 1. Write the extended product indicated by each expression below, do not evaluate. All right, so like for instance, in letter A where I have -9 squared, right? I don't necessarily want you to tell me what that's equal to. I just want you to be able to look at this and know that this is -9 times -9. That's it. All right, now if you happen to know that that's positive 81, awesome, but not really the point right now, okay? Now we can do this with anything, whether it's a variable, a fraction, a number, or anything. So for instance, in letter B, where we have 1/2 raised to the 3rd power, all that means, right, is that I've got 1/2 times 1/2 times 1/2. That's it. That's the extended product that the exponent indicates. So what I'd like you to do is try to write out for each one of these that extended product, but don't worry about evaluating anything. Just write out what the exponent is telling us that the product is. All right, well here we have 2 to the 4th power, right? So that's telling us 2 times 2 times 2 times 2. Simple, right? Now in letter D, we get to our first variable. We have x raised to the 3rd power, also known as x cubed, right? Now x to the 3rd power is simply x times x times x. That's it, right? Nothing more than that, but that is what it tells us. Now let's take a look at some that might be a little bit trickier. Notice in each one of these situations I have parentheses around the thing that's being raised to the exponent. That means everything is being raised to the exponent. So when I have 4x inside of parentheses and then a 2nd power, also known as squaring, right? This is literally telling me that what we want is 4x times 4x. That's it, right? That is what that expression means. And likewise, when we have x divided by y or x over y raised to the 4th power, all that's telling us is x divided by y times x divided by y times x divided by y times x divided by y. And again, your job right now is not to know what that's equal to in any way, but just simply to write out what that product means. Now this is a very important one because there's a negative in here. -5x quantity to the 3rd power, or cubed, again just means -5x times -5x times -5x. That's it. That's the whole deal with letter G. And finally here I've got x plus 3 to the 2nd power, or x plus 3 squared, and that literally just means x plus 3 times x plus 3. Now one final comment on letter H. This was the first one where I left the parentheses there. I didn't here, or here, but you certainly could have. You could have, done this and done this. You could have, but it's actually not necessary. Same thing here. Here it's absolutely necessary. So let me be very clear. If you wrote this down, that's actually incorrect, all right? And the reason it's incorrect is due to order of operations. Remember, order of operations would say that multiplication has to come first and addition, right, has to come after multiplication. So if I were to look at this expression, that would really be x plus 3 times x plus 3, right? This literally would be x plus 3x plus 3. And that's not what this is. This is add 3 to x, and then multiply the results. And that's not what this is. So we're going to cross all this stuff out. Make sure you have those parentheses. All right, so can you take a situation where you've got an exponent and know what it means in terms of this extended product? Now, if we can go in this direction, we also want to be able to go in the other direction. And let me show you what I mean by that. All right, it's important to be able to express repeated multiplication using exponents. Sometimes parentheses are needed, okay? Let's take a look at exercise number 2. Write each of the following products using exponents, do not evaluate. All right, so 7 times 7 times 7 times 7, that's simple, right? That is just 7 to the 4th. No parentheses are needed at all. 7 to the 4th and 7 times 7 times 7 times 7 are the same thing. But let's take a look at letter B. We have 2/3 times 2/3. Now it would be tempting to write something like this down. 2/3 squared. But again, this all gets into order of operations. In order of operations, exponents come before division. So technically speaking, this would be 2 to the 2nd all divided by 3. And the 3 wouldn't be getting squared at all. So really, for this one, I absolutely positively need to put parentheses around that 2/3 because that division has to occur before the squaring. Now, if you want to be safe, you could always put the parentheses here as well, but they're not needed, okay? So what I'd like you to do is rewrite each one of these things in terms of something to some power, all right? And you think for yourself whether or not you need exponents. Pause the video now and go ahead and go through those. All right, so this one. 2 times 2 times 2 times 2 times 2. Simple enough. That is the same as 2 to the 5th. No parentheses are needed. Can you have them around the 2? Sure, but you don't need them. Now this one's trickier. It would be very tempting to just write this. In fact, it really seems like you could write this. But believe it or not, this is really considered in math to be 10 squared times -1, all right? Now remember, a negative times a negative is a positive. This would actually be -100. So in this case, I want parentheses around there. In fact, anytime you have a negative number being raised to a power, make sure that negative number is in parentheses. Let me say that again. Anytime you have a negative number raised to an exponent, get that negative number in parentheses. Otherwise, what you're really doing is doing the positive raised to the exponent and then multiplying by -1. And that's a little bit different. Now, letter E, again, x times x times x, simple enough. That is simply x to the 3rd. But this one again can be tricky. It would be tempting 5y times 5y times 5y to say that that is 5y to the 3rd. But again, the problem here is that 5y to the 3rd is really 5 times y times y times y. It's only one 5, right? So if I want to make sure that all 3 of those 5s are included, I've got to have 5y all to the 3rd. Letter G is very similar. -3c times -3c is -3c to the 2nd. And again, letter H is similar to letter F. This would be 1/2 times x to the 3rd. Again, those parentheses are needed. Otherwise, order of operations kicks in and it makes you do the exponent first and then everything else after that, all right? So be careful. If you've got a single number, a single variable, especially one that's positive, you can always write it without parentheses. But if you've got other numbers in there, or you've got a negative number, then get it in parentheses before you apply that exponent. Okay, let's keep working with exponents. Now, exponents behave in certain ways that are known as exponent rules or exponent properties, depending on, honestly, which textbook you look in. They reveal how bases and exponents interact when multiplied and dividing. Now, just to make sure you've got some basic terminology. In any exponential expression, you've got the number that's being raised to the exponent, that's called the base, and then you've got the exponent itself, and that's called the exponent, right? So literally, if I had something like, 3 to the 7th, and I said, what is the base? You'd say 3. And if I said, what is the exponent? You'd say 7. So it's important to know that the number down here is called the base of the exponent, and we will use that term quite often. So just make sure to know it. Anyhow, let's take a look at exercise number 3. Consider the expression 2 to the 3rd times 2 to the 5th. How can we rewrite this as 2 raised to a single power? All right, so again, here's my point. We're going to be looking now at an exponent rule that basically is if I've got the same base, 2 in both cases, both raised to an exponent, right? How does that work out? What can I do with those exponents? So let's discover that in both A and B. So in letter A, it asks us to rewrite both 2 to the 3rd and 2 to the 5th in expanded form. All right, this is simple enough. Let's do it together, right? 2 to the 3rd, that's just 2 times 2 times 2. And 2 to the 5th is 2 times 2 times 2 times 2 times 2. Whew. All right, so letter B now says, now write the entire product in A as 2 raised to a single power. All right, so in other words, 2 to the 3rd times 2 to the 5th, and let me write this a little bit bigger so we can really see it. And actually, let me write it bigger and bring it down here so I've got more space. Well, 2 to the 3rd times 2 to the 5th, 2 to the 3rd is this, right? And 2 to the 5th, right, this is 2 to the 3rd. 2 to the 5th is 2 times 2 times 2 times 2 times 2. This is 2 to the 5th. And so when I multiply 2 to the 3rd times 2 to the 5th, I get 2 to the 1, 2, 3, 4, 5, 6, 7, 8. And that is no great surprise, right? Because if I have 2 to the 3rd times 2 to the 5th, it really means I have 8 2's multiplying each other. So I have 2 to the 8th. And this brings us to our first extremely important exponent law, rule, or property, depends on what you want to call it. The product property of exponents. When two expressions with the same bases, all right, it's got to be the same number down here. This doesn't work if you've got 2 to the 5th and 3 to the 7th, okay, you're done. But if two expressions with the same base are multiplied, their exponents add. B to the m times b to the n equals b to the m plus n. All right, and again, I hope that property makes sense to you, just as in that last exercise. 2 to the 3rd times 2 to the 5th, I've got 3 2's multiplying 5 2's. I've got a total of 8 2's multiplying each other. So this is simple. Let's take a look at exercise number 4. Rewrite each of the following expressions using a single base and exponent. All right, great. So, what do we have here? Well, in letter A, we have 2 to the 5th times 2 to the 11th. And let me write that a bit bigger. 2 to the 5th times 2 to the 11th. Well, our exponent property says, right, since they have the same base, both bases are equal to 2, then this will be 2 to the 5 plus 11, and that will be 2 to the 16th, which is some enormous number, all right? I don't care what it is, right? All I want to do is use this exponent property. Why don't you use the exponent property to try to rewrite each one of these? All right, now my directions really don't quite make sense for letter D, but we'll get there in a second. In letter B, we've got 10 to the 3rd times 10 to the 8th. Since they both have the same base of 10, we can say this is 10 to the 3 plus 8, and that must be 10 raised to the 11th power, the 11th exponent. Now you do this a lot more often when you're dealing with variables than just normal numbers, right? And this is a good example. Here I've got x to the third times x to the second. X to the third times x to the second, where they both have bases of x, right? So they have a common base, which is x, and therefore this must be equal to x to the 3 plus 2, which is x to the fifth. All right. Now the final one, as I said, kind of violates what I've asked you to do here, but it still illustrates the point of adding the exponents, right? Here I've got x to the fifth divided by y squared times x to the fourth divided by y. All right, well, remember that when you multiply two fractions, you multiply their numerators and you multiply their denominators, right? So if I multiply the numerators, I've got x to the fifth times x to the fourth, which will be x to the ninth. Now in the denominator, I've got y to the second times y. Now you might wonder about what you should do with that given that it doesn't have an exponent sitting there, but it really is y to the first, right? There's only one y there, it's y to the first. So I've got y to the second times y to the first, which is y to the third. And that's the best you can do with that. And there really are two bases in this case, a base of x and a base of y, right? But we've still used that addition property of exponents both in the numerator and the denominator. All right, this is an amazingly, amazingly important property. Now, it's a property though that has to do with multiplication. And the associative and commutative properties of multiplication allow us to rearrange products involving variables and constants in order to write them in simplest form. All right, so let's take a look at that in exercise number 5. Rewrite each of the following products in simplest form by multiplying constants and variables separately. The first is done as an example. All right, so let's take a look at this first one. Right here, and again, let me write this out a little bit bigger, 4x squared times 2x to the fifth. You see, multiplication is fantastic, just like addition is. We've really got 1, 2, 3, 4 things multiplying each other. The number 4, the expression x squared, the number 2, and the expression x to the fifth. Because multiplication really doesn't care the order in which it's done, I can rearrange these things so I can do the 4 times the 2, right? And I can do the x squared times the x to the fifth. It's supposed to be a times symbol. Now the 4 times 2 I can just say is 8, right? That's simple enough. And then x squared times x to the fifth I can say is x to the seventh, right? By adding their two exponents. And that's what I want you to do in each case. Let's do another one together. Let's take a look at letter B. 7y to the fourth times 3y to the eighth. All right, great. So in other words, I can take this thing and I can rearrange it so that I'm first multiplying the constants, the coefficients, 7 times 3, and then I'm also doing y to the fourth times y to the eighth. All right, now 7 times 3, that's just 21. And y to the fourth times y to the eighth is y to the 12th, because I'm going to add their exponents. All right, so what I'd like you to do is attempt to do this for all the remaining problems. We even have a couple that involve fractions, but you'll be fine. Just remember how fractions work. Multiply the tops, multiply the bottoms, cross multiply to simplify, all of that kind of business, and then we'll take a look at them. Why don't you go ahead and pause the video now and work through all the remainder of these problems, and then we'll talk about it. Now, of course, I did the two easy ones and left the harder ones for you, but let's go through them. Here, I've got negative 2t to the second times 5t. So I can say that this is equal to negative 2 times 5, all times t to the second times t to the first, if you need to even write that down. Negative 2 times positive 5 is negative 10, and t to the second times t to the first is t to the third, right? Just add their exponents. All right, let's take a look at one that involves fractions. This can get a little ugly, right? So I've got 1/2 x squared, or sorry, 1/2 x cubed times 2/5 x squared. So I'm going to grab those two fractions, 1/2 times 2/5. I'm going to put them in parentheses. And then I'm going to have x cubed times x squared. Now with the fractions, I can do a little cross multiplying, 1, 1, and now I'm just going to have 1/5 and then times x to the 5th. As easy as that. Okay? Now let's take a look at one that has multiple variables in it. Now this one looks just absolutely horrible, but again, it's all multiplication, right? 4xy squared actually means 4 times x times y squared times 10 times x cubed times y squared. All right, so I'm going to group all the normal numbers together. Those are just the 4 and the 10. Then I'll group the x's together, x times x cubed. Then I'll group the y's together, y squared times y squared. And now I can evaluate. 4 times 10 is 40. X times x cubed, add their exponents. Again, if it helps, put an x to the first there. Whoops, that'll be x to the 4th. And then y squared times y squared, also add their exponents, y to the 4th. All right, now the scariest looking one, definitely the last one. So let's take a look at that. First thing I'm going to do, I'm going to put my fractions together. 7/2 times 4/5. All right, and then I'll multiply those numerators. That's going to be x times x cubed and y squared times y squared. Very similar to the last problem. I can do a little cross multiplying there. I can now get 14/5. In the numerator, I have x times x cubed. That's going to be x to the 4th. And in the denominator, y squared times y squared, y to the 4th. So very, very similar to the last problem with those x to the 4ths and y to the 4ths. All right. So this is a very, very important thing to be able to do, right? Take expressions that have not only variables raised to powers, but also numerical coefficients and be able to kind of group them together, multiply, combine exponents, etc., to get the simplest form of the expression. Let's take a look at one last problem. All right, now one thing I never want you to forget, one thing I want you to remember is that when we rewrite an expression, we do so in order to find one that is equivalent to the original. Equivalent to the original, i.e. it has the same value as the original, no matter what value of the variable is used. All right, let's take a look at exercise number 6. Consider the product 4x times 5x squared. Letter A, write this product in simplest form. All right, awesome. This shouldn't be too tough. Why don't you pause the video now and write this in simplest form just like we did in exercise number 5. All right, great. Well, I'm going to group the normal numbers together, 4 times 5. Group the variables together, x times x squared. That's going to be 20 times x to the 3rd. All right. Now, again, I want to hammer home. The point here is that this thing, 20 times x cubed, should be equivalent to this product no matter what value of x I put in. Now, I can't put in every value of x because there's an infinite number of them, but at least I can test it. And let's do that in letter B. Evaluate both the original product and your expression in A for x equals 2. All right, so what I want you to do is I want you to take x equals 2 and I want you to put it in here for x, and I want you to figure out what all that is equal to. That should be the first part. Then I want you to take x equals 2 and put it into this one. That should be the second part. And if we've done our work correctly, then the two values should end up being the same. Pause the video now and go ahead and do that test. All right, well, the original is going to take me more time than the simplified version, and that's kind of the point, right? We want the simplified version. So the original version, right, will be 4 times 2 times 5 times 2 squared. Now remember, in terms of evaluating an expression, we always want to do what's in parentheses first. So that's 4 times 2 is 8. And we want to do exponents, right? So that should be 5 times 4. So that's going to be 8 times 20, and that is 160. Now notice that took me, quite a few lines of evaluation to get down to 160. Now let's do it with the simplified expression, right? So with The simplified expression, what I should have is I should have 20 times 2 to the third. 2 to the third is 2 times 2 times 2, that's 8. And 20 times 8 is 160. Again, if these two came out different, then you would know that either the two expressions weren't equivalent, or maybe we had made a mistake in our evaluation. But either way, the point of almost every algebraic manipulation like this is to produce an expression that is simpler than the one that we began with for some purpose, whatever that purpose is, which you'll get to in further courses. All right, let's wrap this up. So, today we reviewed just basic notions of exponents, what they mean, what they tell us, how we can take something that's got an exponent in it and write it as an extended product, and vice versa, if we've got an extended product, how we can condense it using exponents. But very importantly, we learned about the first fundamental exponent property, which is when you multiply two exponential expressions that have the same base, the number on the bottom, I guess, then their exponents will add. All right? Now we're going to see a lot more exponent properties in coming lessons. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.